Lecture 2, Part 1, How Simulation Works. So let's recall our definitions, our fundamental definitions. We have entity, which is an object or component processed by the real-world system. We have resources or servers, and we have events. These are these discrete things that occur. Remember, in our example, the entities were patients, the resources or servers were rapid triage nurses, and the events were arrivals of a patient or completion of a service. In general, this will be more complicated, or it can be more complicated, but this is sort of the most fundamental kind of simulation we're going to be working with this semester. So for the discrete events, what that means is that if we're only interested and sort of fundamentally interested in arrivals and completions, even though the time is continuous, right? This is this continuous line. The discrete events are the time points where there's either an arrival or a completion. So you can see here in orange, these are arrivals. And in the green are our service times. And note that this orange stuff, this is all inter-arrival time. So A1 is an inter-arrival time, when in general AI is an inter-arrival time, which means the time between arrivals. And you can get the actual arrival times by adding those together. A1 plus 0 is T1. That's an arrival. A1 plus A2 is just another arrival. And A1 plus A2 plus A3 is a third arrival. And then you get your service times, and that gives you your departures. So, for example, C1 here is the departure of the first arrival. So it arrives at T1 and then is served until C1. And you can see that's just going to be A1 plus S1. It gets more complicated when you think about even the departure of the second arrival, right? Because it's no longer as simple as saying, well, it arrives at T2, so we just add the service time. And why not? Well, because we have to wait for the first arrival to finish service. So its actual completion time is C1, which is the completion time of the first arrival, plus its service time, S2. Okay. And this is where this starts to get combinatorially more difficult. Why simulation becomes something that it becomes a good tool to analyze this more and more complicated situation. Because if you think about it, this is just a single server and a single arrival process, and already we have something that gets quite complicated. Okay. So when we are thinking about the simulation, we're basically going to take snapshots. The first snapshot will be time 0, and that's E0. Then the second snapshot will be the first arrival. The third snapshot will be the next event. So each of these E's represent events, right? So events here are either, for us, they're either arrivals or departures. And of course, in general, it could be more complicated. Okay, so we need to get just a bit more formalism to be able to run our simulation. So we think of the system state. That's going to be a set of variables that contains information to describe the system at any point in time. That will include the number of entities processed, the remaining time for entities currently in process, and descriptions of the entities waiting for process. It's going to be more general again for more general systems. Basically, you need as much detail as required so that you can uniquely identify what should happen next and what is currently going on in your system. So we'll start with a hand simulation example. This just means we're going to compute it by hand, not use a computer. the generic idea is we have blank parts arriving to a drilling center. So when we say blank, this is just the name of the part. They're processed by a single drill press, which can only process one item at a time. They immediately exit once processing is complete. And I should note they also immediately enter service once the drill press is free. Blanks are processed first in, first out. So this is sort of your typical, if you arrive first, you get served first. Note that that's not always the case. This is, in some sense, what we've just described is called a single server queue, and it's one of the most fundamental queues that we'll be interested in this semester. We can pre-generate all the random inter-arrival times and service times before we even start the simulation, and we did that because that makes the hand calculation a little easier. And this is sort of a good, I think, straightforward example of how we can use randomness to serve us rather than be the subject of it. So a lot of simulation is really how do we express agency over randomness. In this case, there's no need to wait to generate all the times. As long as we generate them randomly, we could just do this in advance and know what they are, and then better structure our simulation or calculations accordingly. So there's our inter-arrival times, there's our service times. Okay, so here is going to be a sheet that we use for the snapshot for this system. You can see that we have clock section, a system state section, a system statistics section. The clock time, that's going to be what is the time of the simulation. The event calendar, that's going to be the list of the next events and the time until each next event or next event time approach. And in particular, what's going to be in here are the arrival, the next arrival time, and the next departure. Remember, those are our events that we're interested in, and really it's the time to these. So there's going to be the time until. Okay, and so it's a combination of these two fields here, which is going to let us calculate all the other times in the sheet. And you know, we're going to update these things as it's required in order to do all the calculations we want. So we're kind of using this sheet to help us with our calculations. And you'll see what I mean when we do the example if it's not clear yet. Now we have the system state. We need the number completed. That's how many entities have been served. So this is going to be the number. You can think of it also as how many entities have left the system. The entity in service, that's the number of entities currently in service and their the number of the entity currently in service. So that'll identify which entity, or in this case, which drill part is currently in service and its remaining service time. So the remaining time until it leaves the system. Finally, we have in this section, we have the queue. So that's the number of entities, or the number of drill parts in this example, that are waiting to be served. They also will include their arrival time and their service time. So the time that they arrived in system and the amount of service time they are going to require from the drill press. Over here we have the system statistics. We have B of T. That's going to indicate, it's a 1-0 variable that indicates whether or not the resource, the drill press in this case, is busy at time T. So that's going to be a step function. It'll be either stepping to 1 or it'll be stepping down to 0. And Q of T, this is going to track the number of entities in the system at time T. Q here is quantity, so it's total number, so it will include the entity in service plus the length of the queue. That's also a step function. It turns out for the simulation, the example we'll only need 4 in the horizontal. So again, a step function that's going to step up to either 0, it'll be at level 0, 1, level 0, 1, 2, 3, or 4, and it'll reflect the number of entities currently in the system, the number of parts currently in the system. So I'm going to end this first part here. This is the snapshot card we're going to use for our hand calculations. It's not the only way you can keep track of a simulation, but it'll be helpful for what comes next.